All right, find all the solutions of the system of given equations. So the technique here, in my opinion, is to use matrices to do all this in your calculator. It's a 2-row and then a 3-column, 2 by 3. I mean, this can be done by hand, but again, if you just write the coefficients 1/5, -1/3, 1, 1/4, 1, and -3, and then you use RREF, you will get the correct answer. Now, there are a few exceptions to this. I mean, there's the case where there's no solution and when there's infinite solutions, but well, we can cover that. But when I enter this in, 1/4, -3, so I get the matrix 1, 0, 0, 0, 1, -3. So this over here means that x equals 0. That's what this top row means. And the bottom row means that y equals -3. So the exception to this is when you get a bottom row of all zeros.
Mhm.
But that's only true if you have 2 equations. If you have 3 equations, well, we'll just stick with that for the moment. Why can't I get more room down here? Okay, the bottom row of all zeros means that the solution is dependent, and that's when you use this y equals y of x, but we don't have that here. If the bottom row looks something like this, zeros, and then there's a 1 on the right, that means there's no solution.
So it's like 0, 0, then 1.
Yes. Which again we don't have, but that is
It's because it's like 0 equals a number.
it's right. Like at 0x equals 1. That's it's impossible. Okay, so I'm just doing a search here for 4.2. 4.2 has several options.
And
Let's
then
go.
when would it be infinitely many solutions?
That's the dependent one.
Oh, okay.
That's the row of all zeros.
Okay.
Okay, so let me do question 17. This one has a system of 3 by 3 equations and 3 unknowns. This is from 4.2. So again, you want to make, actually this has got 4 equations, which is fine. So this one would probably good to do because we'll see some of the behavior that we were talking about. So 1, 1, -1, -4, just writing it's called the augmented matrix. And you don't have to write these out, but I am just for emphasis here. And then you want to get all that into your calculator. It's a 4-row because you got 4 going across, and a 4-column. I'm just entering this into my calculator right now. Most common errors come from just not entering the values correctly. So just if you see something weird in your output, check that you've entered them correctly. All right, so this one has, and I guess I can snip this in. That would be maybe more helpful here. So when I enter this in the calculator, I get that doesn't work real. You get this row of zeros, but the problem is because you have 3 variables, you're going to get a row of zeros in there. So you actually just ignore the last row in this case. Ignore the bottom row. So you can just put a line through it, I guess, and then this top one means that x equals 12. This middle one means that y equals -12. And then this last one means that z equals 4. All right, 4.3, a couple options here. Actually, several. All right, I'll do question 1. there's quite a few from 4.3. So that might be a good way to do this. Can you just stand by for just a moment?
Mm-hmm.
Sorry about that. They're like if I maybe one way to figure out what sections you think will be emphasized would be to like count how many are from each section and see, like in this case there's 3 or 4 from 4.3. So that gives you an idea of like, hey, maybe she's going to emphasize this. So the
I
very
also found the test review too. If we want to look at, if we can go through like these, like through the 5.5, and then if there's time, we can look at the other review too.
Okay, great. So the variables are the x, y are given here, x, y, and z, and then you just got to convert the equations, these word problems into there. And I said before, there's always a mapping. So it's always like all they're going to change are these numbers in red. So if you have really good detailed notes, you actually could just put these numbers in. So it says that each section of finite math has 40 students and earns the college $40,000 in revenue. Each section of applied calculus has 40 students and earns the college $60,000, while each section of computer methods has 10 students and earns the college $19,000. Soon the college wishes to offer a total of 7 sections. Okay, so each of these is a section. So we can see an equation from that. Accommodates 220 students. That's the 40, 40, and 10, and bring in that much in revenue. That's the 40,000, 60,000, 19,000. So we've got 3 equations here to come up with. So the first is the 7, total of 7. So that's the x plus y plus z equals 7. The 220 students, that's you've got 40 students for the first class, 40x, and then 40 for the applied calculus, that's 40y, and 10 for the computer methods. And then the revenues, that's the big one here. That's the 278,000, 1, 2, 3. And then you got 40,000x plus 60,000 y plus 19,000 z. And from here, it's just a matter of solving this through the same methods we talked about before. These problems always have a solution. You should almost never see a scenario where there's no solution for them. 40, 10, 220. Okay, so the answer that I get is 3, 2, 2. And like I said, the only thing that'll change is these red numbers. So you can see where those map to. The 7's there, the 220's there, the 278's there, and the 19 comes down there. All right, let me look for section 4.4. There is no 4.4. Okay, 4.5. No 4.5. Do you know if it skips? Maybe goes to 5.1. Seeing some 5.1.
It should. Yeah, 4.1, 4.2, 4.3, 5.1, 5.2, 5.3, 5.5.
All right, we got it here. So I got there's several different questions here for 5.1 because they're introducing you to matrices. So there's quite a few that they could ask. This one, I'll remind you, when you're adding or subtracting, which is the case here, when you're adding or subtracting, your answer is the same size as these. So this is a 3-row by 2-column. So that means your answer is going to be a 3-row, and 2-column. So you'll have to use this arrow in to change the size on that. And I recommend entering these matrices into your calculator. And then you just use the operations. Like sometimes it might say like 2a minus 3c, or a minus 2c, or whatever. It's going to be that simple to do. So that's one example of this. Let me see what the
What
other
about
five.
like she was teaching us something to do with like I think it was like a and it was like x plus a minus it was like an input thing with I.
I did see that here. That comes in. Yeah, let me. So I can do 4. It's part of 5.5, but it's probably okay to jump to it now.
Yeah. Oh, I just realized that I have homework on 5.5 due also. When we can, I mean, there's 5 questions to it. We can just do one of like a few of them
Yeah.
on
Okay.
the homework.
Do you want me to switch to
Yeah.
that now? Okay.
Yeah.
Let me do that. Just waiting for WebAssign to load. Okay, it's loading back. 5.5. All right. Yeah, there are 5 questions. The one that you were just asking me about is number 5. So let me do that. The other ones are different than this, but
Okay.
we'll see here. So the they're telling you that the identity matrix minus A, the inverse of that equals this. And so they want to know by how many units should each sector increase production. Huh. Is that really okay? I'm actually not sure how to proceed at the moment. So let me just check check here and see what I see. This is an odd question. I mean, I've not seen this before. The they want to increase by 1 unit. So they call something here, which I guess we'll just have to write down. They call this D plus is 1 1 1, and that comes from this 1 unit right here. Okay, and then they're telling you that the change in production, like this you have to know this. The change in production is the identity matrix minus A inverse, and that's what this is up here, times D plus, and it has to be on the right side. So what you see here is they take this matrix 1.3, 0.5, 0, 0.4, 1.5, 0.2, 0, 0, 1.6, and then you multiply it by 1, 1, 1. So the output of that, okay, this is a 3 row by 3 column, 3 by 3, and then this over here is a 3 by 1. So your final answer is a 3 by 1, and that's how you get the sectors 1, 2, and 3 up here. I think the mechanics of this are very simple once you understand that this is the process. But it's probably good that we did this because you'll at least have something to write down in your notes. So just use your calculator again to do this. I'm going to enter this in since it's a homework question. I'll write down the answer.
Wait, so sector. So you put them both in together and multiply them.
Yes.
Oh, and that is all equal to okay. So I don't really have to worry about like I minus a to the -1 because they already give it to you.
Yeah, and that's what I was wondering. I was like, why are they
Yeah,
giving
that's
this?
what I'm.
So they give you that, and so I just put mine in is as A and B, and then multiply them together. So the output here is 1.8, 2.1, 1.6. Let me check that here. Let me enter it in and see if that's what in fact. Works out nicely. Yep, that's it. Now, the first few questions here are totally different than this. I mean, they're
Then
well,
let's do some.
okay. So 3 is a good one to do next because it's actually like an intermediate step of what we just did to explain. So let me grab this here. Number 3. Been helping students a long time with this class. I mean, this is new for me. This section, maybe they emphasizing it now more. So the value of x we just found is the identity matrix minus A inverse times D. So we have to do that now. We have to actually do these calculations. So in this case, I is the identity matrix. It's 1, 0, 0, 1. And you're subtracting A, which is 0 0.2, 0 0.2, 0 0.4, 0 0.5. So I'm just grabbing those numbers. So you would perform this operation, and then you would take the inverse.
Wait, so where did you get the I minus A inverse?
From the previous problem, I know that's what x equals. So
because it's called an external.
Yeah, it's this external. Well, the demand vector is D. The production vector X comes from this formula here, which I should have been explained, or I don't know. It's what it's just it's given, I guess, when you know this. So, these steps in here, like if you call this A, which is totally cool to do, you could call this B if you wanted in your calculator, and then this could really be C. And then your calculator, I think your calculator is an inverse button, but it's inverse B minus C times, I'm sorry, B minus A times C.
Where did you, so then what is the 1, 0? What is B from?
So the identity matrix depends on the size of A. So the identity matrix, let me come down here. I stands for identity matrix. And a 2 by 2 looks like I just showed you 1, 0, 0, 1. A 3 by 3 looks like 1, 0, 0, 0, 1, 0, 0, 0, 1. So you can see that it has ones down the diagonal.
Okay. And then A was given.
Yeah, A is given. So so you have this formula up here to do.
Okay, got it. Okay.
So I wrote down the answers that I got. I'm just gonna practice another version and see if these are
I got that too.
in the right order of magnitude. Yeah, they are. So um, that's good. I would think that that's something they might ask you to do on the test.
And then you knew that I was 2 times 2 because A was 2 times 2.
Yes. Yes. So the I, if you're going to add or subtract matrices, just like what we did in the previous problem here, or ones up above, which I can't seem to scroll to. That's bad. Let me get back to where I can do this. Okay. So in the one of these earlier problems, like here 27, you can only add or subtract of the same size. So when we're doing this problem that we just did, if A is 2 by 2, then the identity matrix is 2 by 2. The question 4 is a 3 by 3, so your identity matrix is 3 by 3.
Okay.
So 1 and 2 are just calculating A, and I think you can actually probably just like practice another version to see how they got the answers if you're not sure.
Okay.
Happy to go through them, but I'd probably recommend going back to the review at this point. Up to you though, your choice.
I don't know. Maybe just go over number 1.
Okay. So snipping number 1 in. Have you used the practice another at all with WebAssign before?
I think I have before.
Okay, so the really nice thing about it is you can just put in garbage values, and when you check your score, it gives you an option to show the answer. Some instructors even show you the solution. So let me snip this one in so you can see, because sometimes it's just easier to see where the numbers come from. So in the practice problem here, which I'm snipping down below, here is the practice problem, and you can see that 1 unit of wood are needed to produce 1 unit of paper. So sector 1 is paper, and sector 2 is wood. I guess wood is on the rows or papers. I don't know, but this number comes from right here,
Right.
and then this number comes from right here. And that's all you've got to be able to do. And then this number is down there.
Okay.
So you just have to know that mapping. There should be a little bit more
Yeah.
background information into like why sector 1 the row or the column. I'm not sure. Units of wood are needed to produce 1 unit of paper. So 1 and 1 is down there. Units of paper used to produce 1 unit of paper. Okay, that's up there. Maybe it's, I don't know, maybe it's paper, wood. Yeah, I think that's how they've organized this in the table. So for your problem, if we scroll up here, this is 0.6, this is 0.3, and then 0.04 to grab those values. And that's what I meant by you can sort of figure out where they're coming from. These are concepts used in another class, which some business students take. It's transition matrices for processes. If you're into like supply chain analysis, that you would see something like this. Okay, you're up to 7 out of 9. Should we keep going, or do you want to move back to review?
Well, if the next other 2 problems are like ones that we've already done, then we can just go back to review.
Yeah, I think we can. Let's go back to review. So I think we left off at 5.1, and I saw a problem that was in 5.5, and that's what caused us to transition here. Let me see what else is in 5.1. adding matrices, multiplying matrices, subtracting matrices, and then identifying elements in matrices. Let me throw this one in, and then it'll take under 30 seconds to do. So you definitely don't want to get any of these wrong because they're just straightforward. It's always row by column. This one has 1 row and 4 columns. A13 means first row, and 3 means third column. So that's the value of 3 right there, that number right there. Okay.
Wait. 1 times 4. Oh, it's first column, third row. Okay, I'm just gonna write this down really fast.
It's first row and then column, yeah.
Okay.
All right, so there's several questions in 5.2, but after scanning them, they're all the same. It's a calculator problem. I don't even know if we're going to do it, but I just want to remind you that you multiply, and in this case, you have to make sure that you can actually do the multiplication. So this first one here has 1 row, 3 columns. The second one here has 3 columns and 1 row. What should the size be of the answer? And if you're not sure, you can just do it because it'll tell you that it's a 1 by 1.
And why is it a 1 by 1?
It's always the outside dimensions. So these have to match the inside ones to be able to do it, to do the multiplication. If they don't match, then it's undefined. If they do match, the outside dimensions is the size of the solution, and the order matters. Like you have to do this one first, and then the one on the right second. And that what I meant by when I said if you just do the calculation, it'll tell you the size. It gives you a 1 by 1 when you're all done.
Yeah. But then if it were to be undefined, what would that look like?
Your calculator would say error.
Error.
When you try to.
So if I just do it like 2 times to make sure, and if I get error, then it's error, and if I get an answer, then it's gonna be the answer.
Yes.
Okay.
All right. So 5.3. Okay. 5.3 is inverses. There's only 2 questions, so we'll just do 19 here because it's the other one just asks if it's an inverse or not. So we need to be able to find the inverse. So the best way to find the inverse is to enter this matrix into your calculator, and then use the inverse A, or I don't know if maybe it's A to the -1. It's possible that it does not have an inverse, and you would get some sort of error on your calculator when you do that. But always check, that you entered it correctly, like you've been saying you'll do.
And then the inverse, I got 1, -7, 27, 0, 1, -4, 0, 0, 1.
That's right. Yeah, I got that too. Perfect. Okay. So those are the questions from 5.4. 5.3. The other one just asked if the 2 were inverses, and to do that, you don't have to. So 5.5, actually, 5.5 has several questions in it, so we should probably do these again. Well, yeah, maybe. So 5.5 actually is pretty heavy in your review. I can't believe that when they ask you the ones that you barely studied. 3 is the one we did not do from your review or from your homework question 4. It's the same thing, it's just different numbers here. X is the identity matrix minus A, the inverse of that times D. So in this case, I is a 3 by 3. Minus A, that's over here. And then you take the inverse of all that times D, which is given. If you didn't have this formula, you would just not have any shot on this. So, okay. What do we want to do here? Do we want to, do you want me to get the answer? Should we go back into, maybe we should go back and do the homework since
Okay, well, I'm just gonna.
it's the same question. I'd rather do that one, but if with different numbers, up to you.
Um, like you'd rather do the homework
Yeah, because it'll have
question?
the right numbers in it.
Oh yeah, that's fine. This is from review the
This is from
review.
the review. Yeah.
Okay, got it.
All right, you are given a matrix. Okay, so same thing here. It's x equals I minus a inverse times d. So you can use d. You can make b your identity matrix if you want 1 0 0 0 1 0 0 0 1. I'll get that in here though. So a equals 0.2. All right, so we got some large numbers here, but the answer I get is 29,000, 27,500, 36,000.
Do you think so? Do you suggest keeping like you plug in you keep A as A and then make
Yeah.
you plug in did you plug in D and like C?
Yes. Yes.
Okay, got it.
There is a way to make the identity matrix, but you're
Yeah.
it's not necessary to explain it. It just make another matrix and enter it.
Mm-hmm.
Okay. So this is the other question that they this is the other question that is in your homework, and I am not sure how they came up. Television units, television news, and surface units of radio news. Each unit of radio news, of course, radio news. So this is just a mapping. I'm just gonna practice another, get the right values, and then we can look at how they're mapped into the answer here. So this isn't real helpful. The let me snip this in. So in the practice problem, so forget about these. So the 0.5 that comes from there. 0.7 is here. Let's see where that comes from. The 0.4 top right, and then 0 is bottom right. So the 0 comes from the fact that it says no radio there. What isn't clear to me is which is the row and which word is it television news and radio news, like which. I think it's like, I'm not sure, but I think it's like television, radio.
Okay.
But it's a little odd. But nevertheless, here in your problem, 0.6 goes here, 0.7 goes here, 0.5 up here, and 0 down there. Just mapping those values. And this one just wants you to enter them in. You don't have to do any calculations or anything.
Units. Sorry, I'm just writing it down.
It didn't like the answers that I just provided. Oh, because I entered one of them in wrong. That would be no partial credit. Okay, now it's correct. Okay, so we can go back to the review.
Okay.
And we've got 7 minutes left here. So
Maybe some word problems, probably.
yeah, I think that'd be good. That'd be good to do. The hamburger problem. Okay, we can do this.
Can we do one that's like, I feel like the hamburger problem I can probably figure out, but the ones that are like the weird, like, the ones that I can't really wrap my head around because they're about like sci-fi. Remember, like, are there any of
The
those?
zombies. Yeah, you
Yeah.
kill. Yeah. So I don't see that. I see the bagel store question, and I see one about perfume.
Okay.
I think the perfume one is more unclear.
Okay.
All right. So X is rose oil, Y is oil of fermented prunes, and Z is alcohol. All right. It turned out that it was using as 3 ingredients: rose oil of fermented prunes, and alcohol. Okay. Each 28-ounce econo-sized bottle contained 8 more ounces of alcohol than oil of fermented prunes, while the amount of alcohol was equal to the combined volume of the other 2 ingredients. So that second one here, while the amount of alcohol equal to the combined volume of their 2 ingredients, that means that alcohol Z is equal to X plus Y. It's using 3 ingredients to make a 28-ounce bottle. But we know that the 28-ounce bottle contained 8 more ounces of alcohol than oil of fermented prunes. Okay, so here I think what this means is that X plus Y plus Z equals 28, but we know that 8 more ounces of alcohol than oil of fermented prunes. So we know that Z is equal to 8 plus Y. It's either that or it's Y equals Z plus 8. I'm having trouble decoding how this is written. Each bottle contained 8 more ounces of alcohol than oil of fermented prunes. So if Y is let's just say Y is 6, then it has to contain 8 more ounces of alcohol. That's Z. Than oil of fermented prunes. So 8 plus 6 is 14. That seems to work. I think that's right.
Mm-hmm.
So these are your 3 equations. You can rewrite them into standard form. So like this first one, we can write X plus Y minus Z equals 0. The second one, we can just grab X plus Y plus Z equals 28. And then this last one here, if we keep the number there, move the Y over, you have minus Y plus Z equals 8. And whenever there's not a value in a position, that means that it's 0.
Mm-hmm.
So I'm going to enter this in. Hopefully
What
we get
about
a.
the amount of alcohol was equal to the combined volume of the other 2 ingredients? What does that mean?
That means that Z is equal to. I'm sorry. That's the Z equals X plus Y.
Oh, okay.
So if we get this right, the only numbers that are going to change are the 28 and the 8. But let me just confirm that this is correct. This does work. So the 8 goes down here and the 28 goes there. And your answer is 8, 6, and 14. Let me just check that actually works in the answer key here. All right, it likes that.
Okay.
It likes that. So let me grab the bagel store question, and then we can set it up, but maybe not solve it.
Okay.
All right, so bagel store orders, cream cheese, super smooth, and bagels best. Amazing. Okay. The costs, okay, so it says 1 month, the total order of cream cheese came to 100 tons. That's X plus Y plus Z equals 100 tons. The costs are given in the next equation. So that's 80X plus 50Y plus 65Z, and that equals 66,080. So the last one here is given that the store ordered the same amount from CCC and BBF. So that means that X equals Z. So you have your choice here. You can either substitute these in, or you can just put them all in standard form.
Mm-hmm.
Which way do you think you'll do it?
Probably standard form.
Okay, so that means this last one's the only one that's kind of gets weird. It becomes X, 1X plus 0Y minus 1Z equals 0. That's what this one goes to. And then this is equation 1, equation 2, and equation 3.
And then you put it in, and then you get the 3. Is there ever, and you said there's never really no solution for these?
No, these always have a solution. They always have nice solutions as well.
Okay.
All right. That's it for today. Thanks again for scheduling. If you think you might need my assistance on the exam, just contact me.
Okay.
A little before.
It's just on Zoom, so like,
yeah.
I'm sure I'd be able to, like, if I need to, like, take a picture or something.
Sounds good.
To you if I'm struggling. So it's at noon. So I'll just let you know.
Okay, sounds good. Thanks so much.
Okay, thank you.
Bye now.
Bye.